Hello, welcome back to our YouTube channel. Today we are going to see the problem Saf loves beautiful strings. Okay, this is the easy version. So what we are given, we need to compute fs for the given binary string s. Okay, and what is that? The beauty of a binding string t defined as f of t, and how it is defined. So let's say initially we have a score 0, and then we can repeat this process k times. And what we'll do, we can choose any index and delete it, and after deletion we will count the different number of indexes such that ti is not equal to ti plus 1, and we need to add k to the score. So that is the problem. Okay, so let's see how can we solve this problem. So let's say in the first example we have 0 0 1. Okay, so how many pairs are possible right now? In starting we have two pairs only. Okay, in starting sorry, not two pairs, my bad, we have only one pair. This one, this is the pair. Okay, so we can delete this one at the start and still we have one as the pair. But now there are only two elements, and if we delete anything, that means we can't have anything. It will be one, and this is the only answer we can have. Okay, so let's see some other case as well. This 1 1, here there is no valid answer. We can delete anything, but answer will not change, so answer will be 0 anyway. So let's say here in this case, this is the interesting thing, like 0 1 0. Now if we see directly, then there are two different indices for which t of I is not equal to t of I plus 1, for this and this, right? But we need to delete one, like first, then we can calculate the score. So if we delete this, then there will be only one pair, right? So you can add only one, and if we delete another, it will be 0. That's it. So to better understanding, we have one more example, this thing, and with this we can understand. Let's say we have 1 1 0 1 1. Okay, initially we know we have two pairs, this and this one and this one. Okay, so two pairs initially we have like this. But what we can do, we can delete this, still we have two pairs. We can delete this, still we have two pairs. But now if we delete any one of them, the pairs will be reduced. The pair will be reduced by 1. So 1 2 2 1, that is 5. Okay, now I'll show you one more example for better understanding. So what is the thought process? So let's say we have 0 1 0 1 0 1, right? How many values are there? How many pairs we can say? There are 5 pairs. This one, this one, this one, this one, and this one. Okay, 5 pairs. And if we delete this, how many pairs? How many pairs? We have 4. Okay, and if we delete one more, how many pairs? 3. If we delete one more, 2. If we delete one more, 1. So that means this is a sequence. This is a sequence we are forming. So to calculate the sum of the sequence, we know whatever is this top value, let's say this is n, then we know we can do this thing, n plus 1 divided by 2. This thing we can do. So if somehow we are able to find the values till here and then we can add this value, we'll get our answer. Okay, so how can we find that value? That is again a question. So we'll calculate the count pairs, and initially what we'll do, by this example you can see we have 3, let's say. So the size of this n, let's say size, this is 3, and the pairs, let's say p, how many pairs? We have 2. Okay, so initially the number of pairs, this value will be repeated somehow, like here we are repeating now 2 times. So how can we check this repetition, how many times this value will be taken? So this value will be taken by n minus 1 into, sorry, not into, minus 1, this is again a minus. Okay, so let me change some color on this. Okay, so we need to do yeah, we need to do minus this p, and how many those available, we will multiply this. So in this case 3 minus 2, this is 2, minus 2, this is 2, and this will become 0. So if we multiply anything with 0, it will be 0. Now we know after this value it will form a sequence, it will form a sequence like 1 0, this kind of sequence. And we know now for this value we have a this n. So what is this? 1 plus 1 into 1 plus 1 divided by 2. If we do this, it will be 1. We can add our answer coming from here and here. Okay, so I'll try to show the same thing with this example. In this example, how many pairs are there? 2. That means p equal to 2, and the numbers size is 5. So 5 minus 1 minus p, that is 2, into p, that is 2. This is 4 minus 2, that is 2 into 2, that will become 4. Now what we need to add? We will reduce this value by 1 and then we'll add p into p plus 1 divided by 2. This is p is equal to 1, so 1 into 2 divided by 2. This is 1, so 4 plus 1, 5. This is the solution for this problem. We can know how many times it can contribute. This is the thing, we are calculating this count pairs, and these many times the count pairs will be same, and after that they will be reduced. That's the solution for this problem. So we'll see some code. Okay, so what we'll do, we'll declare n and s and initially the answer. And one thing we need to take care, we need to define hashtag int long. Okay, everything is in long. So we have defined count pairs as well, and we'll try to iterate and get all the count pairs, and we'll calculate here. This is n minus 1 count pairs into count pairs. We'll get the value and we'll reduce the count pairs by 1, and then we'll add the summation formula from ai to an, 1 to n, sorry. This is the formula, and then this is the answer. Hope you understood this solution. Like this video, subscribe the channel. Thank you and keep coding.